Given a binomial expression 1 plus x raised to the power of n, the general term in the expansion is given by tr plus 1 is equals to n times n minus 1 times n minus 2 all the way up to n minus of r minus 1 divided by r factorial times x raised to the power of r. So we have already derived this in the proof of binomial theorem for the general term. So let's apply this to do some problems. So in this particular question, we are given an expression, and we have to find out the general terms. So first, let us begin by simplifying the given expression, which could be written as 4 minus 5x squared raised to the power of negative half. So what we have done, we have taken the expression in the denominator to the numerator. Now we're going to factor out the number 4. So we have 4 raised to the power negative half times 1 minus 5 over 4 times x squared raised to the power negative half. So 4 raised to the power negative half can be written as 1 over 4 raised to the power of positive half times 1 minus 5 over 4 times x squared raised to the power negative half. So that means we have 1 over, so the 4 raised to the power of half is also known as square root of 4, which is 2, times 1 minus 5 over 4 times x squared whole raised to the power negative half. So this is the simplified form of the given expression. Now we have to find out the general term. So the general term is given by t r plus 1 equals to, so we consider the half first, and now we apply the general term formula for the binomial expression. So we have n, which is negative half times negative half minus 1 times negative half minus 2 all the way up to negative half minus r plus 1 divided by r factorial times x. So x here, negative 5 over 4 x squared raised to the power of r. Now we have to simplify the terms, the values. So the first one will be half. Let's keep it the way it is. So we have negative half times negative half minus 1 will be negative 3 over 2 times negative half minus 2 will be negative 5 over 2 all the way up to, so we have negative r positive half divided by r factorial times negative 1. So we have pulled out the negative 1 from negative 5 over 4 x squared. So we have negative 1 raised to the power of r times 5 over 4 whole raised to the power of r times x raised to the power of 2 times r is twice r. So this is equals to half times, now what we're going to do, we're going to factor out minus 1 from each of the terms. So that would give us minus 1. So we have r number of terms. So that would be simply negative 1 raised to the power of r. Now we will be left with only the positive terms, which will be half times 3 by 2 times 5 over 2 all the way up to r minus half. So let's write it as r minus half divided by r factorial times negative 1 raised to the power of r times 5 over 4 raised to the power r times x raised to the power twice of r, which will be equals to half. Now what we're going to do, we're going to combine the minus 1 raised to the power of r. We have two of them, so that will give us negative 1 raised to the power of r plus r. So that would be simply twice of r times half times 3 by 2 times 5 by 2 times all the way to 2r minus 1 over 2 whole divided by r factorial times 5 over 4 raised to the power of r times x raised to the power 2s of r. We have half times, now we can rewrite it as negative 1 squared raised to the power r, and we can see that here we have half times 3 by 2. We have 1 over 2 is the factor 1 over 2 is multiplied to each of the term, so we combine them together, and since there are r number of terms, so we'll get half raised to the power of r. And now we're left with only the odd terms, which will be 1, 3, 5 all the way up to 2r minus 1 divided by r factorial times 5 over 4 whole raised to the power r times x raised to the power twice of r. Now we have half. Now the exponent of half is 1, so we can combine it to the exponent of half, which is r here, so that would give us simply half raised to the power r plus 1. Now negative 1 squared will be positive 1, and 1 raised to the power r will be simply 1. So we're left with 1, 3, 5 and 2r minus 1 divided by r factorial times 5 over 4 raised to the power of r times x raised to the power of 2r. So let's arrange it, and the general term will be t r plus 1 is equals to 1 times 3 times 5 all the way up to 2r minus 1 divided by r factorial times 2 raised to the power r plus 1, since it's in the denominator, times 5 over 4 whole raised to the power r times x raised to the power twice of r. So this is the general term. Let's do another problem. So here we have the expression 1 minus x raised to the power of negative 4. So the general term will be t r plus 1 equals to n, which is negative 4, times n minus 1, so that is negative 5, times n minus 2, which is negative 6, all the way up to n minus r plus 1 divided by r factorial times x raised to the power r. Now we do one more simplification here before proceeding to the next step. So this is negative 5, negative 6, and we have negative r, negative 3 divided by r factorial. So here x, it's not x raised to the power of r, I missed it, it's actually negative x raised to the power of r. So that would leave us with negative 1 raised to the power of r times x raised to the power r. And we pull out all the negative ones from each of the terms, so there are number of terms, so that would give us negative 1 raised to the power of r over r factorial, and we write this negative 1 in the front, so we'll be left with 4 times 5 times 6 all the way up to r plus 3 divided by r factorial times x raised to the r. So we have negative 1 raised to the power of twice of r divided by r factorial. I have written r factorial twice, so there will be only once, times, now we're going to multiply 1, 2 and 3 to the numerator, and then we're going to divide by 1, 2 and 3 in the denominator, and we have x raised to the power of r. So negative 1 raised to the power of 2r is simply 1, like we did in the previous problem. So we have 1 over r factorial. Now 1 times 2 times 3 all the way up to r plus 3 is simply r plus 3 factorial divided by 1, 2, 3 times x raised to the power of r. Now r factorial, now 1 over r factorial can be broken down and written as r times, no, I'm going to leave it as r factorial. However, I'm going to break down the r plus 3 factorial, and that can be written as r plus 3 times r plus 3 minus 1, which will be simply 2. Then r plus 2 minus 1 would give us r plus 1, and times r factorial. This was done so that we could factor out r factorial from both the numerator and the denominator. So we factor out r factorial from the numerator and the denominator, and then we are left with r plus 1 times r plus 2 times r plus 3 divided by 1, 2, and 3 times x raised to the power of r. So this is the general term for the binomial expression. For the binomial expression, r1 minus x raised to the power negative 4. Let's do another problem. We have to find out the general term. So we have to first simplify the given expression, which we can rewrite it by factoring out 2. So we have 2 times 1 minus 3 over 2 x squared whole raised to the power negative 2/3. So we have 2 raised to the power negative 2/3 times 1 minus 3 over 2 x squared raised to the power of negative 2/3. This can be further simplified as 2 raised to the power negative 2/3 1 plus negative 3 over 2 x squared raised to the power of 2/3. Now we will find out the general term, which is tr plus 1th term. So tr plus 1 is equals to n, which is negative 2 over 3 times negative 2 over 3 minus 1 times negative 2 over 3 minus 2 all the way up to negative 2 over 3 minus r plus 1 divided by r factorial times x raised to the power of n, and our x here is negative 3 over 2 x squared raised to the power of r. Now we simplify the values. So the first one will be negative 2/3 times negative 5/3 times negative 8/3 times negative r. Then we have negative, we have positive 1/3 divided by r factorial times negative 1 raised to the power r times 3 over 2 raised to the power of r times x raised to twice of r. Now we're going to take out the negative number 1 from each of the terms. So we have negative 1 raised to the power of r times 2/3 times 5/3 times 8/3 all the way up to r minus 1/3, or we can say 3r minus 1 divided by 3 divided by r factorial times -1 raised to the power of r times 3/2 raised to the power of r times x raised to the power of twice of r. Now we can combine -1 raised to the power of r, since there are two of them, so we'll get -1 raised to the power of twice of r. Now we also pull out 1/3 from each of the term, and there are a number of terms, so we have 1/3 raised to the power of r, and that leaves us with 2 times 5 times 8 all the way up to 3r minus of 1 divided by r factorial times 3/2 raised to the power of r times x raised to the power of twice of r. Now -1 raised to the power of twice of r is simply going to be 1. So we have 2 times 5 times 8 all the way up to 3r minus 1 divided by r factorial times 3 raised to the power r times 3 raised to the power of r divided by 2 raised to the power of r times x raised to the power of twice of r. Now here we can factor out 3 raised to the power r, since it is present in both the numerator and the denominator, and that would leave us with 2 times 5 times 8 times 3r minus 1 divided by r factorial times 2 raised to the power of r times x raised to the power twice of r. Now, one more thing which we have to take into account. So when we simplify the given expression, so we have 2 raised to the power -2/3 multiplied to the simplified version. So we have to multiply it to the general term. So therefore, the general term is actually 2 raised to the power -2/3 times 2 times 5 times 8 times 3r minus 1 divided by r factorial times 2 raised to the power of r times x raised to the power of twice of r. So this is the general expression. Let's do another one. So in this particular question, we have to find the first negative term in the expansion of 1 plus x raised to the power of 7/2. So we begin by assuming that the r plus 1th term contains the first negative term. So we find out the value of t r plus 1, which is simply going to be n 7/2 times 7/2 minus 1 times 7/2 minus 2 all the way up to 7/2 minus of r minus of 1 divided by r factorial times x raised to the power r. So here this term, so since we have assumed that this is the first term, this is the term which is going to be negative, this is possible when 7/2 minus of r minus of 1 is actually less than 0. So this is possible when this is a negative number. So let's find out the value of r. So we have 7/2 minus of r plus 1 is less than 0. So that is give us minus of r plus 9/2 less than 0. We have negative r less than -9/2. We multiply both sides by -1, so that would flip the sign of the inequality. So we have r is greater than 9/2, and 9/2 is 4.5. So the smallest integer value of r, which is just greater than 4.5, is equals to 5. So we have the value of r here. So the value of r is equals to 5. So that means this would means that the sixth term, that is the sixth term, is the first negative. Is the first negative. So let's try to find out the value. So we have t 5 plus 1 is equals to, so we plug this value of 5 into our general term. So we have 7/2 times 7/2 minus 1 times 7/2 minus 2 times 7/2 minus 3 times 7/2 minus 4 divided by 5 factorial times x raised to the power of 5. Now if you get confused how to write this general term, so remember that our rth term is 7/2 minus of r minus 1. So let's try to write in that particular fashion. So the first term will be 7/2 minus of the first term, so we're talking about 1 minus 1. This is r value is 1, so that's why we got 7/2. Then the second, for r equals to 2, we'll have 7/2 minus of 2 minus 1. So that gave us 7/2 minus 1 as the second term. Then we continue, we have 7/2 minus of 3 minus 1 all the way up to 7/2 minus r5 minus 1, because r value is 5. Will continue up to here, divided by 5 factorial times x raised to the power 5. Now we plug all of this value into a calculator, and this gives us -7/256 x raised to the power of 5. So I can say the sixth term, in the sixth term the first negative appears, and its value is -7/256 times x raised to the power of 5.